Hello friends, welcome to my YouTube channel MKS Tech Talks. So in my YouTube channel, you can find one playlist with the name DevOps Training Series, Zero to Hero. So in this playlist, you can find all the required DevOps tools to become a DevOps engineer, the Linux, Git, Jenkins, Docker, Kubernetes, Ansible, Terraform, and AWS Cloud. So I will upload all these topics in the coming days. So for now, you can see the Linux videos, the complete Linux videos, whatever we need to become the DevOps engineer. So I covered all the Linux concepts in this Linux series. So next, I will start with the Git, and to get all my updates, please subscribe my YouTube channel MKS Tech Talks. So this is a very good opportunity. Please utilize and please like, share, and subscribe my YouTube channel MKS Tech Talks. Okay. So here, what is a Git? Git is a version control system. Okay. So it is a version control system. So we are calling it VCS. VCS. Okay. So another means Git is version control system. Also we can tell it as source code management tool, SCM tool. Okay. And source code management tool. Okay. So source code management in short we are calling as a SCM. SCM tool, source code management. Okay. So for here, what we are doing with the Git is, so we are going to maintain the code from the different development teams. Okay. So in the real time, what is going to happen is we'll have different development teams. So every development team will work on their specific feature. Okay. So that particular feature code they are going to push into the version control system. Okay. So here in the version control system, again we have different types. Okay, so we have different types of version control systems so we have distributed version control system and centralized version control system. Okay, so version control systems CS types. So we have centralized version control system, and distributed. Okay, so version control system. So these are the different types of version control systems we have. So coming to the centralized version control system. So here there will be one a remote server. We will have one remote server. Okay. So there will be one remote server. So this remote server will maintain all the updated code from all the development teams. Okay. So there will be one remote server which will maintain all the updated code from all dev teams, from all the dev teams. Okay. So if while working with a centralized version control system, right? Here every development team has to directly do the changes in the remote server only. Okay. So if any team member want to do any code changes, right? He has to directly connect it to the remote server. If we want to connect it to the remote server, we need internet. Okay. So to do any code changes, okay. So to do any code changes, code changes, internet is required because we have to connect it to the remote server. We are not doing anything in the local server. Okay, so to do any code changes, internet is required. Required. Okay, so okay, so even for a single command, if you want to push, right? So to do any code changes or to commit, simply we can say to commit any code changes, internet is required. Okay, and if there is no internet, work will be halted. Okay, if there is no internet, work will be halted. So this is one of the drawback we have with the centralized version control systems. And also here, so while working with branches, so working on branches is difficult. Creating the branches is difficult. Working on the branches is difficult. Okay, so working on branches is difficult. Working on branches is a difficult process. Difficult. So always we are going to get merge conflicts while working on the branches. Okay, so we'll get merge conflicts. Merge conflicts while working on the branches. While working on branches, which are difficult to solve. Okay, and so these are the some drawbacks we have with the centralized version control system. Okay, and here due to these drawbacks, nowadays distributed version control systems are very popular. So what is this distributed version control system means? So this distributed version control system also will have one remote server, like a centralized version control system only. Okay, so here also all the team members, all the development team are going to push their changes to the to this remote server only. Okay, so here also we will have a remote server, and all the updated code will be available in the remote server only. But here the thing is, if if the development team has to do any code changes, right? It is not required to directly do the changes in the remote server. Okay, so that is the difference here. So there will be one remote server, so which will maintain this in the same way we may update it from all the development team. Okay, so here also the same feature will have. Okay, and here now even though the finally the updated code will be available in the remote server only, right? But so every developer will have, so every team member will have, every team member will have its local copy of the code. Local copy of the code. Okay, so every team member will have its local copy of the code. So in his local copy, he can do the code changes. Okay, so means no need to do any code changes directly in the remote server. Okay, so like in centralized version control system. In the centralized version control system, what is happening? So if any team member want to do any code changes, he has to directly connect it to the remote server, and he has to push the changes. He has to commit the changes to the remote server, even for a single command also. Okay, but with the centralized version control system, it is not required. Okay, so every team member will have its own local copy. This local copy will have all the updated code. Okay, so if he want to do the any code changes, directly he can do the changes in the local copy only. No need to connect to the remote server every time. Okay, so every team member will have its own local copy of the code. Okay, so they can do the code changes. Okay, they can do the code changes in their local copy. Okay, so in their local copy, in their local copy, and whenever the code changes, all the code changes are done. Okay, so after that So they can push the changes. They can push the changes to a remote server. That is what is going to happen with the distributed version control system. So that is the main difference here. Okay. So as every team member is having its own local copy, so to work on the code, internet is not required here. Okay, why we need internet here? So in the previous case, so to commit the changes to the remote server, so we have to connect it to the remote server. To connect it to the remote server, we need internet. But here we are not directly connecting every time to the remote server. So only if all the changes are done, then only we are going to connect it to the remote server. In the remaining time, no need to connect it to the remote server. We can do the code changes in our local copy only. Okay. So always internet is not required here. Even though there is no internet, the development team can do the changes in the local copy. Okay. So here, if internet is not there, if internet is not there, okay. So for dev team will work on their local copy. Work will not be halted. Okay. So work will not be halted here. So whereas in the case of centralized version control system, so to commit any code changes, internet is required. If no internet, work will be halted. Okay. So work will be halted here. Work will be halted. That is a problem here. Okay. So okay. Whereas in the case of distributed version control system, so even though there is no internet, so the development team will do the changes in their local copy only. No need to bother about the internet. Okay. So this is another advantage we have. So and here with the centralized version control system, so always there is a dependency with the internet. So these are slow. These are slow. Why these are slow? Why these are slow? Always we have to connect it to internet. Okay, so always we have to connect it to the remote server. Okay, so these are slow. Whereas in distributed version control system, so always we are not going to connect it to the internet. So these are fast. These are fast. Okay, so this is another good advantage we have with the distributed version control system. Okay, and working on branches is not that much of difficult with the distributed version control system. We can easily create the branches and we can easily merge the branches. And whenever there is a merge conflict, right, we can easily resolve the merge conflicts in the distributed version control system. Okay. So working on branches is easy. Easy. We can easily resolve the merge conflicts. Okay. So these are the differences between centralized version control and control system and distributed version control system. So due to these differences, so nowadays most of the organizations are using most of the cases distributed version control systems only. Okay. So for here for distributed version control systems, examples are, so Git is one of the distributed version control system. Okay. So here for centralized version control system, so examples we have like SVN subversion. Okay, so subversion. So like that, different uh, mm, version control systems we have. Okay, so under distributed version control system, Git we have and Bitbucket. Okay, so Bitbucket like that, different version control systems belongs to the distributed version control system. Okay. So, any doubts up to now? Any doubts here? Is it
No,
clear?
no, yeah, it's clear.
Okay. So now due to these advantages, right, now we are going to learn Git. So if we are familiar with Git, we can work on any distributed version control system because the functionality will be same on all the version control systems. Okay. So for coming to the Git, so here, so Git is a distributed version control system. Okay, Git is a distributed version control system, and while working with Git, right, we'll have um, uh, different stages. Okay, so it is a distributed version control system. Okay, now, so before going to the stages of the Git, so what these version control systems are doing? Can you tell? What is the purpose of these version control systems? Why we are using these version control systems? So version control systems are used to maintain the different versions of the code. Okay, different versions of the code from the development team. Okay, so any doubt here? How the versions we are getting? Any doubt? Can we forward or is it clear? So if we need
Yeah,
more
it's clear,
information,
sir.
okay. So if you need more information on the versions, right? So we already discussed it, right? So we are going to work on agile methodology. Okay. So in the agile methodology, so dev team will work on the sprint basis, right? On every sprint, one release will happen. Okay, so every sprint will have different version of the code. Okay, at sprint one will have version one code, and sprint two will have version two code, like that. Okay, so all these versions of the code will be maintained in the Git. Okay, so what this Git is doing? Git is going to maintain all the versions of the code from the development team. Okay, so Git is a distributed version control system. So now, so Git will have, so Git will have, Git will have the different stages like, okay, so stages we are calling as the local repo and remote repo. Okay, so there will be two stages while working with the Git. Okay, so what are the two stages means? So there will be local repo and remote repo. So local is nothing but the device where we installed Git. Okay. So local is nothing but the device where we installed Git. So if we install Git in our laptop, okay, so our laptop will become the local repo. Local repo. Okay, so remote repo is, so we already discussed here, right? There will be one remote server. So this remote server we are calling as the remote repo. Okay, so local repo is nothing but our local device where we installed Git. Okay, and remote repo is nothing but some remote server like so github.com or bitbucket.com. So like that remote servers, like this remote servers, we are calling as the remote repo. Okay. So www.github.com, www.bitbucket.com. Okay. So like this, Git will have two stages. One is local, another one is the remote repo. So in the local, what is the local? Local is nothing but our local device. So if we install Git in our laptop, right, our laptop will become the local. If we install Git on the virtual machine, we are going to work on virtual machines only, right? So, sorry, in the cloud missions, right? That cloud mission will become the local. Okay. Okay. Now this local will have again three stages. So one is working directory, okay, staging area, and local repository. So these are the three stages we'll have in the local. Okay. So if you need here, so this is like a local, okay, and this is like a remote repo. Let us consider. Okay. So this local repo is nothing but our laptop. Okay. So this under local again we'll have three stages. Three stages. So what are the three stages we have? So one is working directory, okay, and staging area, and local repo. Okay, so the combination of these three we are calling as the local. Okay, so this is like a remote repo. So remote repo like www.github.com. Okay, so now from our local, this is the local repo. This is the local. Okay. Now, from our local laptop, from our local device, so what we have to do is we have to move the changes to the remote repository. Okay, these are remote server. Okay, so we have to push the changes to the remote server. We have to push the changes to the remote server. That is what we have to do. Okay, so if we want to push our local changes to the remote server, we have to follow these three stages. Okay, so we have to follow the three stages. What are the three stages we have? So we have working directory, staging area, local repository. So these three stages we have to follow. So what we have to do here is, so here we have to initialize working directory. Okay, so we have to initialize working directory. And once we initialize the working directory, so we can do the code changes in the working directory. All the code changes, all the new code changes always will happen in the working directory only. Okay. So once we do the code changes in the working directory, so we can push that code changes to the staging area. Okay, so from the working directory, we can push the changes to the staging area. So this staging area is like a temporary storage location. Okay, so this staging area will be available logically only. We cannot see the staging area physically. Okay, so through some commands only, we can see what are the files we have in the staging area. Staging area is like a temporary storage location. So why we need this staging area means, so in the working directory, let us consider we do some code changes. So we move the changes to the staging area. If we don't want to push that changes to the remote repository, so simply we can revert the changes from the staging area. Okay, so that is the purpose of the staging area here. Okay, so once we have changes in the staging area, from staging area again we can push the changes to the local repository. Okay, again we can push the changes to the local repository. So this flow we have to follow. This flow we have to follow in the local. Okay, so means all the code changes will happen in the working directory, and the code changes will be moved to the staging area. From staging area, these will be moved to the local repository. So this local repository, if we have any changes in the local repository, only that changes will be moved to the remote repository. Okay, so if we have some additional changes in the working directory which are not in the local repository, that changes we cannot move to the remote repository. Okay, so whatever the changes we have in the local repository, only these changes so we can move to the remote repository. We can move to the remote repository. Okay, so other changes we cannot move. So that is the reason. So whenever we do any code changes in the working directory, these changes we have to move to the local repository. Okay, so this is the flow. This is the flow how Git is going to work. So is it clear? Is it clear? So if
Yes.
you understand
Yes.
this, then only you can follow the total Git. Okay, otherwise you will be in trouble. Okay, the same concept we are going to use in the coming 6 to 7 classes. Okay, if you understand this flow, then only you can understand the Git. Okay, now, so coming to this working directory. So what is working directory? So working directory is nothing but some folder. Okay. So it is like any folder. Okay. So how to create the working directory? So to create the working directory, just we have to be in a folder. We can create a new folder, or we can use a existing folder, whatever it is. Okay. The recommended way is try to create the new folder. Try to create the new folder and just initialize the git. Okay, so working directory is nothing but the folder where git is initialized. It is initialized. Okay, so this folder we are calling as the working directory. Okay, so how to initialize the git? So to initialize git use so git init command. This is the command we have to execute. Okay. So once we execute git init command, the folder wherever we are executing git init command, that particular folder will become the working directory. Okay. So this is how we are going to create the working directory. So once we initialize the git, what will happen is, so in the given folder, okay, so one .git folder will be created. Okay, one .git folder will be created. Once we got the .git folder, so all the changes, every change, what, sorry, so what are the change we are doing in this particular folder, right? So every change will be monitored by the Git. Okay, so once Git is initialized, okay, so every code change in that folder will be monitored by Git. So Git is going to monitor each and every change, whatever we are doing in the working directory. Okay. So now, so initially, so we are going to work on the working directory only to do the code changes. So once these code changes are done, then what we have to do? We have to move the changes to the staging area. Okay. we have to move the changes to the staging area. So once the code changes are done, so we have to move the code changes to the staging area. So to move the code changes to move code changes to staging area, yeah, the command is okay. So we have to use git add file name. So this is the command we have to use. Okay, so by using git add command here, we have to use so git add command, git add. Okay, so by using this git add command, we can move the changes from the working directory to the staging area. Okay, so what is the staging area? So what is the staging area? This staging area is nothing but some temporary storage location. It is a temporary storage location where our code will be stored for some time. Okay, so this staging area we cannot see. This staging area will not be available physically. Okay, staging area will not be available physically. So this will be available. This stage will be available logically only. We cannot see this physically. Okay, so there and through some commands only we can access the files, whatever the files we have in the staging area. To access that files we have to use some commands. Through some commands only we can access the files available in the staging area. Okay, so mm, now, so once we have changes in the staging area, so what we have to do? If we have changes in the staging area, these changes we have to move to the local repository. Okay. So how to move the changes from staging area to the local repository? So if we want to move the changes from staging area to the local repository, the command is git commit command. Git commit command we have to use. Okay, so whenever we execute git commit command, the changes from staging area will be moved to the local repository. Okay, so to move the changes, to move the changes, to move the code changes from staging area to local repo, the command is so git commit. Git commit is the command we have to use. Okay, so once we commit the changes, these changes will be moved to the local repository. From where we are getting these changes? We are getting these changes from the working directory. Okay, from working directory, the changes will be moved to the staging area. From staging area, changes will be moved to the local repository. Okay, so this local repository, okay, so once we got the code into the local repository, so this code is ready to move to the remote repo. Okay, so whenever we got the code to the local repository, so this code is ready to move to the remote repository. Okay, so this local repo also, it is also available logically only. Logically only. We cannot see local repo also. Through some commands only, we can see what are the files, what is the code we have in the local repo. So through some commands only, we can see this local repo. Okay, so now once we have code in the local repo, this code we can move to the remote repository. Okay, So to move the code changes from local repo to the remote repository, so we can use git push command. Okay, so here, so to move the changes from local repository to the remote repository, so the command is git push command. Git push. By using git push command, we can move the changes from local repository to the remote repository. Okay, so to move the code changes from local repo to remote repo, the command is git push command. Okay, we have to use git push command. So once we push the code will be available in the remote repository. So this process, every team member is going to do. Whatever the process we discussed, right? So this process, every development team member will do. Okay, so every team member will have his own local copy, and he will do the code changes. He will move the code changes to the remote repository. Okay, so what are the commands we had to use? We had to use git add command. What this git add command will do? Git add command will move the changes from working directory to the staging area, and git commit command will move the changes from staging area to the local repository. Git push command will move the changes from the local repository to the remote repository. Okay, so is it clear? So
Yes, sir, it's clear. Yeah.
okay, so now, so let us consider. So there are three members in our team. Okay, there are three members in our team. So now, so dev team member one pushed his changes to the remote repository. Okay, similarly, dev team member two will push the changes to the remote repository, and dev team member three also will push the changes to the remote repository. So now this remote repository will have all the updated code from all the team members. Okay, so this remote repository, so every team member is going to push the change to the remote repository, right? So this remote repository will have, repo will have the updated code, always updated code from all team members, from all the team members. Now, here the problem is, what is the problem here? Now, so again, let us consider we did a sprint one. Okay, we did a sprint one. At sprint one, every team member pushed his changes to the remote repository. Now, on the sprint two, what we have to do? So, whatever the existing code we have, right? We have to enhance this existing code. Okay, so to enhance the existing code, so team member one will know the code pushed by other team members. Okay, every team member has to know, will need some idea on the code pushed by other team members. Then only he can do the code changes in the existing code, right? Okay, so if every team member knows the code changes done by other team members, then only on the sprint two they will do the code changes in the existing okay, so means every team member need the total code from the remote repository. Okay, so every team member has to pull the code from the remote repository to their local. Okay, so then only team member one will know what changes done by other team members. Okay, so similarly, team member two will know what changes done by team member one and three, like that. Okay, so what they have to do is they have to pull. So after the sprint one, okay, so again they have to pull the code from the remote repository. So to pull the code from the remote repository, the command is can use git pull command. Okay, so git pull command, by using git pull command, so we can pull the code from the remote repository to the local repository. Okay, so to push the changes, git push is the command. To pull the changes, git pull is the command. Okay, here. we have to use git pull. By using git pull command, we can get the changes. Okay, we can get the changes from the remote repository. So this remote repository will have updated code. So such that whenever we pull the code, we will come to know the changes done by other team members. Okay, so this is what going to happen. So this is how we are going to work on the Git. Okay. So now what we have to do is to work on the Git, right? So we are going to create again a new instance. Okay, and try to create one instance. So we know right how to create the instance. Okay, so launch instance. I'm giving the name of the instance as Git 730. And so after that, what we had to do? We already discussed, right, how to create the instance. So we have to select the AMI, Amazon Mission Image, Ubuntu Mission Image we are selecting. And so once we selected AMI, then instance type. So T2 micro is sufficient. You can see free tier eligible option here. Okay. So T2 dot micro is sufficient. Okay. Select the T2 dot micro. And after that, key pair. So this is important. So for the first time, we have to create the new key pair. As we already have key pair, we can use the existing key pair. What is the key pair name we used? So PEM file, right? 0905. This is the PEM file. This is a key name. So check here 0905 key pair. This one. So 090525. This is the key pair we are using. Okay. So we already have key. We can use the same key pair. No need to create a new key pair. Only for the first time we have to create the key pair. Okay. So for that's it. No need to do any additional changes. Now launch the instance. Now go to the instances, refresh here. You see, Git 730 got created. Okay, it is in running state. Now, what we can do, we have to connect it to the instance. And here, so connect it to the instance. Right. Okay, we connected instance. So as usual, we have to log in with root user only. We already discussed, right? Always we are going to work with root user only. So log in with root user. Su sudo su hyphen. Now we log in with root user and we have to install the Git. Okay. So Git installation. Git installation. So how to install the Git? So we already discussed it, right? Whenever we are trying to install any package, what command we have to execute? We have to refresh our machine, right? How can we refresh our machine? How can we update our machine? Apt get update. This is the command, right? Okay. So by using apt get update, we can update our machine. So use this apt get update. So this is the regular practice. Whenever we are trying to install any package or any application, okay, so just we have to update our machine. Okay. So after this, what we have to install the Git. So to install the package, what is the command? We already discussed the command, right? What is the command to install the package? What's the Linux command? Apt install package name. So in our case, Git apt install Git. Okay. So to check the Git once we install the Git, right? We can check the Git version by using Git hyphen version. Okay, by using Git hyphen version, we can check the version of the Git. So if we updated our machine. Now, so one thing you have to remember is if we are working with Ubuntu Linux, no need to install the Git. By default, Git will be available. Okay, by default, Git will be available if we are working on the Ubuntu machines, Ubuntu Linux. Okay, just to check the Git version, check whether Git is available or not. So Git hyphen version. You see Git version. This is the Git version we have 2.43.0. This is the latest version here. Okay, so Git version 2.43.0. So on 2.43.0 we are going to work. Okay, so now we have Git available. Now what we have to do? This is our local. Okay, so wherever we have a Git, right? So this is our local. Okay, now what we have to do? Just follow this. Just follow this. We are on local. Okay. So the local device where we have installed Git. We have installed Git is installed. Okay, so that one become local. Next, what we have to do? We have to create working directory. Okay, how can you create the working directory? How to create the working directory? So here we already discussed, right? Working directory is the folder where Git is initialized. This is just a folder. Working directory is nothing but a folder. Okay, so what we have to do? We have to create one folder. Just we have to create one folder. Check whether we have any folders. This is a snap. We cannot use this. This is the system generated folder. Okay. So what we have to do is we have to create our own folder. We have to create our own folder. And once we have folder, so we have to execute git init command inside the folder. We have to go inside the folder. Okay. So inside the folder, we have to execute git init command. So once we execute git init command, so our working directory will be created. Okay. So our working directory will be created. So once we have working directory, so in this working directory, we can do the code changes. We can do the code changes in the working directory. Okay. So then we have to follow the remaining process. Okay, once we have working directory, right? And then we have to follow the remaining process. So from the working directory, we have to move the code to the staging area. From staging area, we have to move the code into the local repository. So while moving the code, we have to use these commands: git add, git commit. These commands we have to use. Okay. So now, if we have code in the local repository, this code we can move to the remote repository by using the git push. Okay, so this process we'll see in the next session. So that's for today. So any doubts up to now? No, sir. It's good. Okay. So next class will be on Monday. So do the practice, complete the Linux, whatever the Linux commands classes we have, right? So complete the Linux classes and try to install Git.